Welcome to this lesson, Introduction to Blockchain Development with Ethereum, presented by Coding Bootcamps. Smart Contract Constructs. A review of information about our instructor, and a review about some classes you may want to look into. So what we have learned so far, we learned about smart contracts, executing smart contracts, developing them, the remix development environment. We learned about public and private blockchains, the blockchain network. We learned about Ethereum and its structure. So now we're going to talk about smart contracts. So Ethereum smart contracts can be written in Solidity, Viper. We saw an example of Solidity in our previous lesson. However, no matter what the programming language, the Ethereum virtual machine deploys the smart contract to the Ethereum network. So smart contracts are meant to respond to events and transactions, and they also are how we build our distributed applications. So as we're going through development, one of the first items we want to take a look at it is the pragma. So pragma is not unique to Solidity. So the pragma is the keyword that invokes the compilers. So Solidity contractors will have different variations of pragma entries, and that version of the compiler must be available. There are different ways to indicate the compiler with the pragma. So we can see greater than or equal to, and these are compiler versions right here. A contract with a caret entry is, it will not compile any version earlier than, in this case, 5.2. And so we can see it right here with the caret, and you can see other variations as well. Greater than or equal to, less than, so an in-between type of pragma. These are complicated. You might want to keep the pragma as simple as possible. So also comments. So code comments are important. Even some of the contracts we're going to take a look at in this lesson will have comments in there about what types of addresses or what roles we'll be running. You can do single line comments with the double slashes, or multi-line comments using the slash star and then star slash. And you can take a look at an example here. Exactly similar to Java, JavaScript, and C++. And then there are Boolean data types. So Boolean data types are a data type that is true or false. And we have here our negation data types here, or our negation operators. Our logical conjunctions, either the double ampersand or the and. Logical disjunction, either the double pipe, or equity with the double equals, or inequity with the bang equals. And you can see examples of it right here. We can see our bools. We can see our bools and they're initialized, and we can see some if statements. And then we also have our integers. So we have signed integers and unsigned integers. So this is the U, prefix U to int is unsigned. And you can see sizes for the integer as well. So we have 8, 256, unsigned integer, and then 256. So think about performance on the blockchain, and you will want to optimize your data. And then with our integers, we also have operators. So we have addition, subtraction, multiplication, division, modulo, and exponential. And these operators are the same as Java, C++, or JavaScript. And again, for the integers, they exhibit the exact same behavior. And you can see here also less than or equal to, equality, inequality, greater than or equal to, or greater than. And you can also strings. So strings must be inside quotes or double quotes. So you can see here two examples, hello and hello world. Strings cannot be directly compared in Solidity. So what Solidity does is compares the hash value of the strings. So if the hashes are the same, the strings are the same. If the hashes are equal, the strings are equal. So there's also an address data type in Ethereum, and there are two versions of the address data type. There is address and address payable. Address payable is the same as address, but also includes methods for transferring and sending. So again, address payable includes extra methods to transfer and send. Address payable supports address, and address payable supports sending Ether to another user's Ethereum wallet. And the address uses the same comparators as integer. So we can see here some examples of a wallet, and you can see here a wallet here. The address payable has the sender. Enums. So enums are custom data types. So enums, you can give them a specific name. They are zero indexed, and you can declare a value. So in this case, we have an enum called user options, or we have a user options enum. We see here, we declare that, and we see the options. So listen, connect, cancel. And then we declare a my option as user option, so which means it has the properties of user options. And then we can see here a constructor, and we want to initialize my option to the option cancel. And then for connect, we want to set it to connect, and so on. Another custom data type are structs. So structs are what we are going to use to model real-world objects. It's one of the tools. So we can see here we have a funder struct. So we need an address and an amount. So you can imagine what kind of data we want to build in here for funder. So again, this is one of the ways that we model real-world objects. Before we continue, let's take a quick look at the application we looked at yesterday. So we see in here that we have our structs. So this is the application we looked at yesterday. And we even have our addresses in here. So please take a look. We see another address here, issuer. So we have our various, a lot of the items that we're talking about now. So please go through this and take a look. Not everything is in here, but a lot of what we're looking at now is in here. You can see that if we used our enum in here to set certain conditions, payments can be made based on a certain condition. And we can see here that arrays are a data structure. So arrays are a way to have a variable with multiple values in different sections of memory. Arrays can be fixed or dynamic, and the size of the arrays can be declared at compile time. Values can be removed or added to the array based on methods push and pop. And the array length is used to add length to the array. So the length property is used. So adding values to the array, removing is a pop. And we can see here we have a strut right here of customer, and then we build an array of customer right here. You can see that we go through, we push different customers on here. So we actually loop through here and build an array of customers. Mappings are another data structure. So this data structure is similar to hash tables in that the values can be accessed using a key. So mappings are a key value type of data structure. So if we want to create a mapping called a customer, every customer gets a key or an ID and then other values associated with it. So to return the Mark Smith, we would request a key equal to 1. So it would be ID equal to 1. We can see here mappings set up here, vendors. So this mapping is called vendors. Another one is called balance. We have our struts here, our vendors, and then we build up. We then build up our mappings here of various vendors. And we also can write certain data to the log. So with a blockchain, nothing is returned to the screen on the smart contract. You can interact with the screen, you can have a user interface, but with the smart contract, you don't. All of the events are written to the blockchain. So events are members of the contract in Ethereum. So an event, when an event is called, its arguments are stored in the transaction's log, and the log information can be seen when the transaction is mined. So the log is part of the record when the transaction is mined. So events are used with init to manage writing to the log. So we can, and also we have loops. So loops have a construction exactly similar to Java, C++, JavaScript. There's a loop header, which consists in this case is a for loop, initialization and condition, and then the iterator, and then the loop will execute until the header condition. It will continue to loop while the header condition is true. And there's also a while loop. So a while loop also has a header condition. So we can see here while k is less than this array length, the expression will loop in the braces. It will loop through the expression in the braces as long as the condition in the header is true. And then there are do while loops, which are exactly similar to while loops, except you can guarantee that the expression will be executed at least one time. Handling errors. So currently right now, the error handling is limited to items such as require or checking ahead of time. Structures such as try-catch may be added in subsequent versions of Solidity, but currently right now there is no try-catch. So to prevent wasteful transactions from happening, we use require. So in this case, we can see require the amount has to be under 1,000. So we set that condition in order to receive a particular balance. If the require condition is not met, the transaction is rolled back. So we can see here a revert is called. And the revert function also triggers an error to display. And then that will roll back the transaction. So no ether is used, there's no wasted transactions. On a blockchain, once a transaction occurs, it's anonymous. So likelihood of reversing that transaction once it occurs is very remote. So we want to prevent transactions until we're absolutely sure that they should happen. So let's take a quick look again at our application. So we can see here, we see the mappings. And we can see here how we add to vendor. So the add vendor function, and what it does, it adds to the mappings. So we see here a vendor count, which is counted right here, the name of the vendor, the address, and the amount owed. So we can see here that's all included in the strut here. So the vendor ID is managed here by the counter. We can see the name, the address, and the amount owed, and that's the Ethereum address. And then we can see here a function where the requires are here. And we can see a for loop. And we can also see some emits in here. So we see our emits in here. So, and we can probably look up here, and see the event too. So what we want to do is we want to compile this. And then we want to deploy. And yesterday, in the previous lesson, we ran it. So take a look at running this. We'll go through very quickly. We'll say that this is Joe's store. And we need to give Joe an address, so let's get an address from here. And say the amount owed is 200. And we want to issue, so we need a receiver address. Two different addresses. This is why comments are important. Let's say this is 500. And if we can do some testing here, test the balance, we can see we have 500 here. So as we go through here, we can click send, and that was successful. And now we can check our balance again. So it's down by 200 because we owe Joe 200. So if we put Joe's address in here, we can see that Joe has 200. Let's just get Joe's address. And I'm using, these names are very long, so copy paste obviously is a good tool to use. And let's try that. Oh, 200. Okay, great. And that was successful. And if we look through here, these logs, we may have to increase this. You can actually see the information emitted in here if you go through these logs. So, and you can see more information here. You can see an address, and but take a look at that as well. So please consult your lab materials for information on how to build and run this lab.